Hello, everyone. Welcome to our class of numerical control again. We often see some holes in the daily parts. For the processing of different holes, CNC system gives different instructions, which are important for ensuring the accuracy and efficiency of hole processing. Now, let's learn the special program for processing the holes. Basic introduction to fixed loop instructions. Firstly, let's learn the basic concept of fixed loop instructions. This is an example of processing a hole, which can be managed by instruction G00 and G01. First, control the machine tool to finish the setting of initialization. Then, control the cutting tool to locate on Z direction. Subsequently, control it to locate on the surface XY of the first hole. Perform cutting to a depth of 23 mm in the first hole, pausing 4 seconds at the bottom of the hole. After pause, lift up the cutter out of the bottom of the hole, and then complete locating and repeated processing of the middle hole and the right hole. Finally, retract the cutter, and then the program ends. Now, the workpiece is completed. In this case, we find that the processing of a hole requires the actions such as locating, cutting, pausing, and retracting. The instructions mentioned before shares a common feature. One program segment can only control the machine tool to complete only one action. This programming is not so complex for a few holes, but it will be troublesome when processing a workpiece with multiple holes just with the conventional programming. Certainly, maybe someone will work out that the process can be managed by the sub-programs learned before. It's really awesome. Let's see the procedure with sub-program. The processing with sub-program mainly makes the actions and instructions of the same structure as a fixed module. Now let's write a sub-program in the main program. First, we need to locate the different holes, and then we use the sub-program to finish the actions concerning on processing the holes. By this, the work amount is significantly simplified. In this case, we find that it's so convenient to use sub-program to process the multiple holes of the same depth and structure. But this way is not helpful when processing the multiple holes of different structures. In this case, the FANUC0I system has specifically designed a set of fixed loop instructions for hole processing in order to enhance the programming efficiency. Just one instruction for fixed loop enables to control the machine tool to consecutively complete the actions of locating, cutting, pausing, and retracting. By this way, the working amount is significantly simplified. So, the principle of fixed loop is that one instruction controls the machine tool to complete several actions. Let's study the basic actions of the fixed loop. There are so many kinds of holes. No matter they're made by drilling, expanding, threading, boring, or reaming, the process of machining these holes usually includes the following 6 actions. Action 1. Control the cutting tool to locate on surface XY. Action 2. Control it to locate in the Z direction. Action 3. Control it to cut along the axis of the hole. Action 4. Control the actions of the cutting tool at the bottom of the hole, like pause. Action 5. Retract the cutting tool to a relatively safe height above the hole. Action 6. Control it to move back to the original height. In the animation, we've learned the general procedure of hole processing in a fixed loop. And in different actions, the cutter moves in different speed as well. For example, the solid line indicates that the tool cuts at the speed of g01, while the dot line indicates the fast motion as fast as the speed of g00. Point R serves as a transition position at the top of the hole from fast motion to feed motion. The speed of action 5 is indicated with both solid line and dot line. It means that in the processing of different holes, the speed of retracting may be fast or slow in work progress, which will be specifically introduced when we talk about reaming and drilling later on. We have known the procedure of fixed loop. So, when processing, how to determine the height of the cutter, which will determine the position of the cutting tool to alter from fast motion to working progress, and how to guarantee the depth of the hole. Next, we will introduce the 3 surface settings of fixed loop. Among them, the initial surface is determined by G00 before the loop starts. The safety surface is determined by parameter R in the instruction. So it's called point R surface as well, where the cutting tool alters from fast motion to work progress. And the safety height is generally 2 to 5 millimeters. The whole bottom surface is determined by parameter Z in the instruction. So it's named surface Z as well, determining the depth of the hole. Importantly, when processing through hole, some overshoots should be left, because there is a drill tip at the end of the drill bit of 3 to 5 millimeters in general. Since we have learned the 3 surfaces and methods of establishing them, please consider that whether the cutting tool should be retracted to the original surface of the program every time we process the hole, in order to enhance the efficiency of the subsequent processing. We need to talk about the 2 ways of returning in the fixed loop, in order to ensure whether it needs to return to the original height. In the 2 ways, different G-codes control the cutting tool to return to different heights, so as to meet different demands. For example, G98 will make the cutting tool return the original level, but G99 will make it return to the safe surface after processing. Which one is more reasonable in the 2 ways? It requires us to choose according to different shapes of the workpiece and the actual situation of the process. For example, when processing such a workpiece, all the holes are on the same surface, so choosing G99 can reduce the cutting in vain and enhance the efficiency. But when processing this workpiece, we have to choose G98 so that the cutting tool can avoid the boss in the middle and the collide and intervene when locating on surface X and Y by returning to the original height. It's a safer way. Ideals are always good. However, how to control the machine tool according to our plans and requirements to complete the regulated actions? we still need to master the instruction codes, which can be identified by CNC Machine Tool. Next time, I will tell you the basic pattern of the fixed loop instruction of whole processing. Welcome to Focus On, our class of numerical control. See you.